This is Algebra 2, Unit 11, Lesson 7, on vertical shifting of sinusoidal graphs. Now, sinusoidal means any graph primarily comprised of either the sine or the cosine function. That's what sinusoidal means. So these graphs can be stretched vertically, as we saw in the last lesson. Other transformations can occur as well. Today we're going to look at the graphs of the equation y equals a sine x plus c and y equals a cosine x plus c. All right, now A, we already know, is going to affect the stretching the vertically because that is the amplitude. All right, that is talking about changing the amplitude to make the graph stretch. What we're going to look at today is the C value, or adding a constant to an equation. All right, now we should have an idea of what happens when you do a constant to equation from previous lessons, back when we did parabolas and that kind of thing. All right, so let's take a look at the function f of x equals sine x plus 3. Well, how would the graph of y equals sine x be shifted to produce the graph of f of x? Well, what happens when you add a constant to something? Basically, you're changing its y-intercept. So if we think of the y-intercept here, this is going to shift up 3 units. Okay, so each point of the graph will shift up 3. So I take each point, 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So you can see each of these points is going to create exactly the same curve, except the entire graph is going to be shifted up 3 units. So there's my new curve. I have exactly the same curve, except it's going to shift up 3. So by adding a constant value, that is going to shift it up 3. All right, so let's take a look at a combination of things. Consider the function y equals 2 cosine x plus 1. So we're going to use our calculator to sketch this. Now notice we have changed the amplitude, and we have changed the constant value here. So let's try this on the calculator. So if I get out my calculator, the first thing I want to do is put in my equation, y equals 2 cosine x plus 1. All right, I want to make sure I'm in radian mode. Notice this says radian right here. And I want to set my window from negative 2 pi to positive 2 pi, because that's what's on the graph. Negative 2 pi, and then positive 2 pi. And then my scale, I'm going quadrantal angles 90 degrees, so I'm going to use pi over 2. There's going to be my scale. Okay, now on this particular graph, it was from negative 4 to positive 4 for the y, so I'll just use negative 4 to positive 4 so we can see what happens on the graph. Okay, so now that I've got all that set, all I have to do is hit my graph key. All right, so there is my new graph. Okay, so let's see if we can figure out what happened here. All right, so I'm going back to my paper here, and if I look at my paper, I remember my cosine graph, the normal cosine graph, I'll even do it in black so you can see it, starts at 1, 0, negative 1, 0, and then back to 1. So going backwards, same thing. So this is my cosine graph. All right, so that is y equals cosine of x. That's the original cosine graph. Now, if we take off our calculator right here, we can see how this is shifted. All right, so this is now starting at 3, and then down to 1, and then to negative 1. So let's see what happens. All right, so let me do it in blue so it looks like it's on the paper. 1, 2, 3, and then to 1, and then negative 1, and then back to 3, and then up to 1, and then repeat the process. Okay, so here is my new graph. This is y equals 2 cosine x plus 1. So let's look at what happened on this. All right, so give the equation of the horizontal line that this curve rises 2 units above. Okay, because our amplitude is going to be 2, all right, notice this, the original cosine graph was y equals cosine x. That has an amplitude of 1 because there's a 1 in front of there. All right, so what we're looking for is how far it rises and falls. So if I put in my horizontal line, let me do it a different color so you can see it, that this is going to be 2 units above. So if I put my line in right here, that horizontal line above, that creates an amplitude of 2. So your amplitude is 2 here, and it's also an amplitude of 2 here. What's the equation of that line? Well, the equation of that line is y equals 1. Now that's how the graph has shifted up. So it has gone from this to this. So this y equals 1 is called the midline. So the plus 1 right here will tell where the midline is. When the graph shifts up, the amplitude will be how many units above or below that line. So this is 2 above the line and 2 below the line. So let's take a look at the range now of this trig function in interval notation. All right, for the blue graph, what is your highest and lowest y? Well, your lowest y is going to be -1, inclusive, and your highest y will be 1, 2, 3. So this has changed your interval from -1, or your range from negative to -1 to 3. It was from -1 to +1. So your midline is the shifting up, and your amplitude will be the number of units above and below that line that the graph falls. So for curves that have the general form y equals a sine x plus c and y equals a cosine x plus c, the value of c is called the midline, or average value of the trigonometric function. It is the height or horizontal line that the sinusoidal curve rises and falls above or below a distance of absolute value of a, which is the amplitude. Okay, so if we are looking for your function here, sketch and label the functions y equals 4 sine x minus 2 and y equals -2 cosine x plus 3 on the grid below. Try it first without your calculator and then verify it, and then state the ranges of each of the equation in interval notation. Okay, so let's do y equals 4 sine x minus 2. What is your midline? Okay, your midline will be -2. So I'm going to draw a horizontal line at -2. Here's -2. That's y equals -2, that's your midline. Okay, now, the sine graph has an amplitude is going to be the absolute value of 4, which is 4. So, for your sine curve, it usually starts at 0. It's going to be, from the midline, 4 units above and below that. All right, so actually, if it starts at 0, it'll be on the midline. So that would be here. Now the next one would be at 1. It's going to be 4 units above the midline. All right, so normally it would go up here, but it's going to be 4 units above the midline. 1, 2, 3, 4. And then it goes back to 0. And then it would be 4 below the midline. 1, 2, 3, 4. And then back to the midline. So basically, you're shifting your graph down 2 and then changing your amplitude. All right, so if I keep going backwards like this, this is going to go back here. This is going back to the midline, up to here, and then back to the midline. So 4 sine x minus 2 will look like this. Okay, pretend that that's nice and curvy, neat. Okay, so notice that there's your amplitude is 4. And this is your midline is 1. So basically, if you pretend that this is the x-axis, you just shifted the x-axis down and went 4 above and below it. Okay, so let's state the range of this. So what is the range of y equals 4 sine x minus 2? What's your lowest y value? Well, it would be 1, 2, 3, 4, 5, 6. So it's -6. And then it goes to 1, 2, 3, or excuse me, 1, 2, there. So it's 2 above the midline, so it's -2 minus 4 gives me -6, and -2 plus 4 gives me 2. So that's where the values came from. So this is y min, and this is y max. Okay. Let's try the second one. Y equals -2 cosine x plus 3. All right, so first of all, what is your midline going to be for this? Well, your midline is going to be at 3. Okay, so let me draw in my horizontal line at 3. 1, 2, 3. There's my midline. Okay, so if that's my midline, what is my amplitude going to be? My amplitude will actually be 2, because it's the absolute value of 2. My cosine graph is going to fall 2 units above and below that graph. Okay, so if the amplitude is going to be 2, normally the cosine graph would start at 1, and also this is negative 2, so it's going to flip over the x-axis. So if my amplitude is 2, it's going to be 2 below the x-axis for the first point. Okay, so if that is my midline, 2 below would be here. Okay, so why, and then it would go, instead of going down, it would go up back to 0, or back to the midline, and then up to above it, back to the midline, and then 2 below it. All right, so that would go up like this, and then come down like this. Oops, pretend that's a nice curve. And then just repeat going backwards. Okay, and then back to here, and then back to there. Okay, so your curve would look something like this. Okay, so your max and your min on this graph. Oh, I got the point in the wrong place. This one should be 2 below. Sorry about that. Did 1 below instead of 2 below. Okay, there we go. Okay, so it's the same. It's the curve going up. It's flipped over the midline because of the negative. The amplitude is going to be 2, and it's going to be shifted up 3. So y min on this, if you start at the midline and then you go down 2, is going to be 1. And y max, you start at 3 and go up 2, you're going to be 5. So your range is going to be between 1 and 5. So there we go. All right. So when you determine the range, you have to know how far above and below the midline you are. All right, so to figure out y min, determine the range. To figure out y min, it would be the midline plus, or excuse me, minus the amplitude. And then for y max, it would be the midline plus the amplitude, absolute value of the amplitude. All right, so y equals 7 sine x plus 4, what would be the range? Well, y min would be, midline would be 4, minus 7 is negative 3. Y max would be 4 plus 7, which is 11. So your, in interval notation, your range goes from negative 3 to 11. All right, negative 5 cosine x plus 2. All right, y min is going to be at, start at the midline at 2, and your amplitude on this is going to be 5 because it's 5 units, and the negative, remember, is flipping it over the x-axis. So this is going to be 2 minus 5, which is negative 3, and y max will be 2 plus 5, which is 7. So your range will be from negative 3 to 7 inclusive. All right, so remember the negative is just flipping it. It's still going to a total of 5 units above or below the midline. All right, let's do one more. Y min and y max. All right, so what is my midline? It's going to be 35, and then my amplitude is going to be 25, so this is going to be 25 below, so that's going to be at 10, and y max is going to be 35 plus 25, which is 60. So your range will go from 10 to 60 for that. Okay, so that's a good introduction to that. Let's save exercise 5 for the next class, and then we will be working on the homework.